Welcome to Media Lesson 2B on multiplication and division. In this first problem, we're going to learn about multiplication applications, language, and notation. So let's get started with some application problems, and we are going to highlight our givens in yellow and highlight our goal in green. So Bernadette is having a party. She invites 5 friends over, and she's going to make 3 cupcakes per friend. How many cupcakes does she need for her friends? So we need to find the total number of cupcakes, and we're given that she's going to have 5 friends over, and each friend gets 3 cupcakes. So let's draw a picture of this. So since I can't draw cupcakes, and cupcakes, we'll think of them as positive cupcakes, or positive 3 cupcakes, I'm going to draw a plus sign represents 1 cupcake. So this is one group of 3 cupcakes for the first friend. That's for the second friend. 3 groups, 4 groups, and 5 groups of 3 cupcakes. So we're going to write 5 groups of 3. So this would be a good way to represent this. And now if we want to find the total number of cupcakes she needs, we could add these or count them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we get a total of 15 cupcakes are needed. So I'm just going to highlight this. How about in blue? Or circle it in blue. So she needs a total of 15 cupcakes. Now you may have seen that this is a multiplication problem, and you may remember that from prior knowledge in other courses. But for now, we're just going to try to develop these ideas of what multiplication is and how we can see it in context. So the next one says you are purchasing 5 DVDs at a cost of $3 per CD. And we want to know what is the total cost. So now we can say, well, each DVD costs $3. So we need to add up $3 5 times. So first DVD, second DVD, third, 4, 5th DVD. So we have 5 DVDs, and if we add these up, we have $3, $6, $9, $12, $15 in total. And sometimes we say that this is the repeated addition model of multiplication. So we can think of 3 times 5 as adding $3 to itself 5 times. Let's look at the next one. You are carpeting a utility room in your house that is 5 feet by 3 feet. And we are asked, how many square feet of carpet do you need? So let's draw a picture of this. I'm going to draw a rectangle. And I'm going to say this side is 3 feet, and this side is 5 feet. Now, the square feet of carpet, that's how many square 1 foot by 1 foot squares fill this up. So what I'm going to do is, since this is 3 feet long, I'm going to cut it into 3 1-foot pieces. And this is 5 feet, so I'm going to cut this into 5 1-foot pieces on this side. 1, 2, 3, 4, 5. Now, the number of square feet is the number of squares that are 1 foot by 1 foot inside this figure. So, let's use a different pen. We have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we need 15 square feet of carpet. Okay. So notice this is another way of thinking about multiplication, is that we need the area of a rectangle that's 3 feet by 5 feet. Now we have one last type of problem. You are walking at a rate of 3 miles an hour for 5 hours, and we want to find how many miles you have walked in total. So let's draw a picture of this. So I'm going to write this one kind of as a number line, so we can think of this as the distance you're traveling. And notice you were traveling for 5 hours. So I'm going to make 1, 2, 3, 4, 5. So up here I'm going to label this in terms of hours. So this was 0 hours, 1 hour, 2, 3, 4, 5 hours. And on the bottom I'm going to label the number of miles you have traveled in total. So the accumulated distance. So at 0 hours you've gone 0 miles. Since you're going 3 miles an hour, after 1 you've gone a total of 3. After 2 hours, you've gone 3 more miles from 3, which is 6. At 3 hours, you've gone 9. 4 hours, 12. And at 5 hours, you've gone a total of 15 miles. So you have walked 15 miles. Okay. So all of these problems are going to be multiplication problems. We can think of them as multiplication, so we don't have to count up all the different plus signs or add $3 5 times or write the numbers in all of these little square feet. We can connect these ideas to multiplication, and you may remember that 5 groups of 3 or 5 times 3 is going to be 15, which is the result we got in each case. So here we thought of 5 groups of 3. Here we thought of the repeated addition model, where we added up 3 to itself 5 times. Here we had an area model for multiplication. We're going to be using this a lot, where you think of the number of squares that fill up a rectangular area that's 3 by 5. And then we had the accumulated distance mile. So this is a number line model. And basically you think of the total distance covered over the time of 5 hours, which gives us to 15 miles. So now that we have these different ideas of multiplication, let's just look at some language and notation before we move on. So we call the numbers we are multiplying factors. So in all of those examples, we could have written 5 times 3 equals 15. Where 5 and 3 are the factors, we don't distinguish between either one, and the product is the result when you multiply the factors. There's a lot of different ways you can be asked for the product or to find this multiplication. So in the last problem, they never said to multiply because they were all in context, but we could say that this is 5 times 3, the product of 5 and 3, 5 copies of 3, 5 multiplied by 3, or 5 groups of 3. These are all different ways in our language that we can refer to this multiplication problem. Also, we have a lot of different ways to write this notation symbolically. So these are symbolic notations. Notice here we have the times symbol, which looks like an X. We usually give this up somewhat quickly because we're going to use something similar to this in algebra, and we don't want to confuse our notation. But your calculator probably has this button for multiplication as well. We use a dot centered in between 5 and 3 to represent multiplication. Notice this dot is not a decimal point. A decimal point would be lower. This is saying 5 times 3. Sometimes we write one or both of the numbers in parentheses and place them next to each other, and the implied operation in that case is multiplication. So we don't write an actual multiplication symbol, and we're going to do this a lot more often when we work with negative numbers than positive numbers, because if we had something like 5 times negative 3, We like to put the parentheses around -3 so we can tell that it's multiplication and that this is a negative sign belonging to 3, not a subtraction sign operating between 5 and 3. Usually we don't really put parentheses around the first number and not the second, but I suppose we could and it wouldn't be mathematically incorrect. But usually we'll either put parentheses around the second number or both numbers.